So I added 5 as an entry.
5 4 seconds.
So the purpose of this tool is just landscape. So I added 5 in here, and I put it in the game council. And just a little bit. Produced by council.
You want to share
Relationship.
Yeah, share screen.
Yeah, so the idea is just.
Share whole screen.
And then
share the whole screen.
Gene here, have all sorts of stuff, and then.
And then go to that.
What's going on?
It's not readable.
Credentials probably.
Okay, you can zoom.
Can we start? Everybody online, everybody in the room?
Everybody is in the room. Yes. Everybody is in the room.
Easy to start in the room, I know. But everybody online, good morning. My name is Dusan Sharma. I'm a researcher at Ohio University from Athens, Ohio. We are going to have joint session on production planning and scheduling and supply chain working groups. I'm going to co-chair it with Farhad Ameri. So he is a IOF chair for supply chain. I'm IOF co-chair for production planning and scheduling. We have a full load of presentations, 4 presentations, 1 panel in the morning, and then more presentations in the afternoon. So we are ready to start. I don't want to list all presentations now, so I'm going to go first with the first presentation, which is going to be review and status of production planning and scheduling working group. Online, if you should be able to see my screen, which is going to go into slideshow mode in a second. Tell me if you can see my screen. So this is overview of progress in IOF production planning and scheduling group. I'll just briefly introduce the group and talk about, we mentioned already interoperability, in probably every speaker in this event mentioned that this is what we are doing, and I explained a few areas of the work that we did in our working group: process aggregation, capabilities, and digital artifacts. So production planning and scheduling working group, I have about half an hour, right?
20 minutes.
20, yeah, this is, we set it together, good.
Yeah.
So mission of production planning scheduling work group is develop semantic definitions for terms and relations that are used in product design, manufacturing, production planning, scheduling, and manufacturing execution. I am co-chairing a working group with Walter Tercaj from Italy and Peter Dino from NIST. And then membership is from all over IOF membership, so North America, South America, Europe. We had about 30 to 20 attendees per meeting in the last 3-4 years, and about almost to 10, which say in the US, they say dozen, which is very close. Regular members, which kind of went a little bit smaller. So I think I'm going to use this opportunity for everybody, IOF members, to join group online and present to kind of increase this participation. This is listing of current organizations and people from those organizations which are registered by our OAGI registration as a members of production planning and scheduling working group. So I think we should go through this mechanism, registering. If somebody wants to join, go through that procedure and register. So I want to now focus on the first item, which is interoperability. We know that product design and development is actually a sequence of tasks, many tasks. But major functions are marketing, which answers questions why. Then design, product design, which answers questions what. So what we are going to, why are we making something? What is that we are making? How we can make it, when and where. So in order to answer these questions, I'm pointing now on screen, which is not shown online. A lot of activities, a lot of tasks, understanding, collaboration between different groups, different expertise. So nowadays we use software, and this is an example of this interoperability problem or idea is, on this slide we see illustration between 3 major tools, not only tools, but major tools that are used in product development in manufacturing, which is PLM, product lifecycle management, ERP, enterprise resource planning systems, and MES or MOM, manufacturing execution systems or manufacturing operation management. Point for this slide is to show that there are shared data in these systems, and some of these systems generate data, some of them use data. Are these data compatible with each other? Are we using them one way or the other? And this green says out, yellow says in. So some systems generate data, some systems use data. Point is there are iterations. So not only, for example, if what we executed in manufacturing last month, we want to use in planning for next month. So it is also that dynamic nature of data. This is framework where this group works. We identify several subdomains for this, our working group. One is, I term here as a use cases, and we haven't paid equal attention to all of those for a variety of reasons. One is process planning. So answering questions, how do we make something? What decision we need to do to basically make plans for our products, be that manufacturing or 3D printing or assembly or biopharma manufacturing, as Sam mentioned earlier. We have to decide how to do things. Then product representation use case, we have to basically have a digital representation of what is that we are making. Manufacturing system design use case, scheduling use case. So we focused on these first two subdomains. Again, reason is personal experience and preferences, though it doesn't excuse us from ignoring other subdomains. Scheduling use case, we had some participation, but not sufficient. I would contribute that to the reason that we have to kind of capture first, how do we semantically capture product and process representation before being able to decide and design other cases. Assembly planning use case as well. Another slide illustrates this previous concept. Essentially, we want to understand systems, designs, planning, and scheduling from mental representations to process representations. Another point is we don't do that, but creating this digital artifact is also process, engineering process. And we don't, at least my opinion is that at this point, we do not cover how to do this. We don't cover how design process works. We're just focusing what is result of design process. Okay. This is listing of IOF core terms that are related for our working group. Complete list is on our Confluence web space. Not all of them are on IOF core, but some of them are basically defined in IOF core. Some of them are concepts that we want to go ahead and define in our process planning and scheduling working group. Our approach is this is busy figure. This is not what is done. This is our wish list. And of course, as a process planning and scheduling work group, we are focusing on reference ontologies for domain. This is what we expect our industrial partners or applications to develop based on reference ontologies. But I see this as a modular. We talked a lot about modularity in IOF, and we still didn't come into conclusion exactly what's there. This is my vision how this should be. So having from top level ontologies, IOF core feeding into our domain reference ontologies, then feeding down into application ontologies. Somebody who is designing cars or airplanes or the computers can work in their own problem space. Okay, so last few years we spent a lot of work in these three areas: aggregation of manufacturing industrial processes, capabilities of resources and the realization in processes, and then requiring the design planning in terms of defining and using digital artifacts. I don't have time to cover all of them, so I'm going to briefly just mention for two first domains and then do a little bit expansion on last area. So process aggregation is based on a 3D model, three-dimensional model of process, manufacturing process model that I developed as a conceptual model that has 3D measures. time, variety, and aggregation. So time refers to precedence in requirements. One, what should be said, see something on also in execution, what something happens before. All manufacturing processes have a time scale, time dimension. Example, before you have breakfast, you have to wake up. That's one example. Variety dimension refers to variety in terms of we make not only one airplane, but we make 10 airplanes, Airbus 319, 320, 330, 350, 380, and such, or Boeing 777, such. We make different models of cars, we make different medications, which is a different topic. And then aggregation, everything is actually one single process, everything in the work. With only one participant in this current continuum, which is called universe. But we have to break this down into small pieces. And this is where aggregation comes into play. Identifying what are atomic processes and how to build them. What are criteria for defining aggregation of processes? Relating that one process is a current part of another or temporal part of another. I'm not going to talk much about this. There is an example here that we did work. We published paper in FOMI in a few years back workshop. I want to give you some ideas about dilemmas. How do we aggregate processes where participants are also aggregated? As I told you, everything is a single process. Timeline from minus infinity, Big Bang, until whenever universe stops being existence, if it happens, with one participant universe. But if A is a continuum part of B, and B participates in process P, does A participate in that process? And then second, if A is a continuum part of B, but A participates in that process, does B participate in that process? I don't have answer today. This is kind of dilemmas. Then if A continuum part of B and A participates in P1 and B participates in PT, is P1 subprocess of P2? Again, talking about overlapping processes, time overlapping processes. This becomes more complicated if we include object aggregates. I have manufacturing, I'm drilling some features from my part, but my machine is in a building. Does building participate in my process? I don't have answer, and this is where we are going to address these issues. Second area is capabilities. We did study and published paper last year on capability of manufacturing resources and capability of complex systems with the concept that for any process, there are multiple participants like resources, and each brings its own capabilities. And this example of axiomatic design principles, how to divide structural decomposition of robotic hand. We used some previous work on capabilities, and ARCO actually was an instrumental part of both of these works. Again, going to details a little bit, how do we do independence on capabilities? We don't want overlapping capabilities because then we are competing. Machine gives us power, tool gives us shape, which are orthogonal, different concepts, but they together work to produce something. And we did apply this on a simple example of CNC machine with a different tool depending on what we are trying to make, and build similar structure. So machine gives 3-axis movement and spindle movement, while tool gives us essentially shape that we want to produce. And third area is digital artifacts. As I mentioned, focus of this production planning, this working group is planning, creating future objects. Designing them, specifying requirements first, then designing and planning them. So this is actually some graph from classes and individuals. I usually like to play with both classes and individuals because we understand how they work together. So for anything that we realize in the real world material artifact, we have to have a requirement specification, design specification, and plan specifications that they have to be related. But do we have these three artifacts, something that actually Sam mentioned in previous presentation in case of pharma, as designed, as planned, as executed, and as realized. Even if I want to have my RPM on my drill bit to be 3,000 RPMs, it may be 2,1995 because material is a little bit harder than standard. How do we represent all of these? We have to keep those because we have to keep those because we have to compare what we produce. Does it satisfy our requirements? And decide is this good quality or not? So a few other slides. One approach is that we currently have, which is using digital artifacts as a information content entity. My argument, we should be evaluating if this is correct approach. Another approach is we have a correspondence relation. So we have a requirements, design, planning, execution stage, and we have instances which all of them with different scopes, if you will, but they correspond to each other. When I make a CAD model of my part, that is digital artifact, and I have to keep it until I make 10 of these or 100 of these, and then for each of these hundreds, they correspond to the same digital artifact. Let me see. I'll give you a short scenario that essentially just illustrates this concept. And I think I worked with Sam and Milos and a few other people kind of try to prove concepts. So simple operation, very simplified operation of car manufacturing, some classes from our IOF core, and then we did assembly planning. So it's Sunday, I finished my planning, I'm ready to start manufacturing. I have my plan, and I have my car as planned. I will have my process, which is going to be utilized. I'm using robot and gripper. Now on Monday, I make one car. I use actually example of my own car, which is Toyota. So this example uses this name. But this is my plan. This is what I did on Monday. On Monday, I can figure out that I made one Toyota and use the same. I may actually use same robot, but may use different gripper. I may specify in requirements, in planning, that I may use one of available grippers, and I may, for Monday, decide which one to use. Then on Wednesday, I do something else, and another car built, and then I may connect. I didn't show all these connections here because it's complex, but I make another one, and I can figure out, I can compare if both of these are processes, are they satisfy my process, and these are products, do they satisfy my planned product?
Yeah, 1 minute.
1 minute?
Time for questions.
Okay.
Maybe we just assume 5-minute question.
So next one is we make something on Thursday, and we work together to figure out that actually, if I make this correspondence relationship between requirement, design, planning, and execution, when I make something, if I collect data, I can figure out what I made. I think I can go back and then, okay, we need to formalize this in our work, and essentially this is what's happening. We are going currently on project, we are going to use these use cases that we mentioned earlier. This is plastic manufacturing use case that Chris was proposed us, which includes both planning and scheduling. Another example with the only design, another example with actually process planning. This is an example that I think this basically one of Will knows already, right?
Yeah, I know that.
Sam too,
Yeah.
which is basically complete what they call model-based engineering, model-based design, specifying geometry and manufacturing requirements. To basically come up into definitions of digital artifacts as planning stage. I'm going to stop here, so, and then have any questions.
I have a comment. We're actually doing a project with CCAM
Mhm.
on, and I think NIST is somehow involved. We're going to be doing some mapping between the as designed and as manufactured, as planned, as measured.
CTM being?
CCAM, it's the Commonwealth Center for Advanced Manufacturing,
Okay.
Virginia.
Mhm.
Yeah, so we're going to be doing, basically it's going to be a geometric association. So we're going to try to
Yeah. So I don't know, whether they use the same software too, but I think the simplest use case is called like process monitoring.
Mhm.
So just to be able to record the data and associate with the kind of at least has to be able to trace back to the plan. Right?
Mhm. I haven't talked much about that progression. Yeah.
there's probably
Question?
some crossover between some of the stuff that I'm going to be doing in MT Connect once I get done with
Probably.
architecture stuff. So we should probably
Yeah.
somehow sync up on that later.
Maybe. Yeah.
Yeah.
Online question?
Yeah.
Okay. We are also missing use cases incorporating a more complex systemic view, meaning connecting ERP, PLM, and MES systems to manage the value system by decision making. This is from Oliver Stoll, which I agree completely, that we are missing use cases incorporating. With respect to more complex, I would say we should work on simple use cases and then build base to go to more complex. I mean, I don't want to study how to connect all this for a car or airplane or engine before I do some simple wise or something. I know, I mean, but when we work on simple use cases, we have to go, when we do any decisions, we have to say how this scales for bigger problems. I don't know if I answered correctly. Thanks. I use my camera.
That was a super answer, thank you.
Good. Anything else? Vote before run, yes.
Now they can see.
Okay, so we ready for second? More questions? Let's see now. So second presentation, something similar for supply chain,
Exactly.
or maybe different, we'll see.
No similar, I can even do not present.
Okay, let me start your, this is overview. Okay, perfect, thank you.
To share.
So online people have the slides, what you can see, right?
Yeah, we are sharing also. You want to share in full screen?
Yeah, full screen, please. Yeah. All right. Yes. So I need to stand on this. Okay. All right, thank you. So good morning. My name is Farhad Ameri. I'm the chair of Supply Chain Working Group, and I'm professor at Texas State University. So it was hotter, warmer and they arrived here than Texas. So I was like, okay, I'm going to Europe, hopefully it's cooler, but it was not the case. But today is much better than the day arrived. So the nature of the presentation is very similar to what Dusan presented. I'll just give you an overview of where we are and what are our next stages in supply chain. So I'll go over just motivation. Why do we need ontologies for supply chains? And then overview of where we are in terms of architecture, some class taxonomies, and some examples of axioms and class diagrams, a few annotation properties, and supporting documentation. And then what are the challenges we have faced and what are the next steps? So today's supply chain are characterized by increased complexity, right? So, and then we have multiple vendors with very different underlying systems. So that's why today the name of the game is supply chain integration and digitization. That's the trend that most companies are moving towards to obviously gain supply chain integration. That's the holy grail of supply chain for different reasons, right? Because it enhances transparency and visibility in the supply chain. It gives us real-time intelligence. Hopefully, it enhances collaboration, communication, and also gives us flexibility and agility. So they look nice. They are very promising, but well, it's not easy, right? So supply chain integration is supposed to be achieved mainly through information flow integration. So if we have that information flow and connection between different parties and different flows of information, then we are in good shape. But there's a problem here. The supply chain software ecosystem is very complex, right? We have a wide range of software applications coming from different vendors, including ERP, CSM, PLM, or supply chain web services. They are all basically coming from heterogeneous and autonomous heterogeneous systems. They have increasing complexity, and they have differences in their underlying business rules and models, and they are basically not meant to collaborate and interoperate. So that's why we have a huge problem, which is interoperability problem, right? So as an example, it's a recent paper, or not a paper, right? It was a white paper kind of on industry leaders. They called for supply chain interoperability between modes, because we have different modes of transportation, rail, air, sea. And for each of them, we have different types of standards. International Road Transport Union, Digital Container Shipping Association, they have their own standards and terminology. International Air Transport Association, International Task Force on Port Call Optimization. So the whole idea is that we have different parties with different standards, and so we'll really lose connectivity throughout the supply chain if we don't have this integrated framework. So there is a real need for that integration in supply chain. So hopefully ontologies can address those problems by providing a common terminological framework and controlled vocabulary and more standardized meaning and semantics, either logic-based semantics or structural semantics, right? But, well, in supply chain, we really don't have a reference ontology, an ontology which is widely used by different companies and industry, and they have failed so far. Because, first of all, we have too many ontologies. The problem is not that we don't have one ontology. We have so many ontologies that are not basically meant to work together. They are based on ad hoc ways, no rigorous methodology for developing and annotating the ontology, short half-life, insufficient organizational commitment. So these are all the problems that we know that exist in most ontology development communities. And hopefully IOF is going to address most of these challenges, especially coming up with a methodology for development. So in the supply chain working group, the objective is to, first of all, identify the requirements for a reference ontology, and then develop the organizational structure and capability, supply chain processes, supply chain structure, Otherwise, we cannot define the boundary and requirements of the ontology. So right now, the supply chain reference ontology imports IF core that they in turn import BFO and annotation vocabulary. And you can see the IRI structure for the ontology. Well, but that's maybe the IF where we are actually hoping to move toward. So we have BFO as our glowing sun of the universe, so in the center, and then we have a domain-independent orbit. We have IF core, and some bunch of moons, as you cannot read them, right? So basically, right now, we don't have this modularization yet, right? So IF core is one single ontology, one single AL file. Scroll is one single AL file, but in long run, it's not maintainable, or like it's very difficult to manage large monolithic ontologies. So we should come up with the strategies. So each of these planets needs to have their own moons, which are those topics under the ontology. So our Big Bang happened in 2016, as Serum described. So give us a few million years to actually produce something useful. But that's where we are now. So I'm just putting everything in single AL file, but hopefully we should have like facilities ontology, traceability ontology, logistics ontology, organization ontology. They're all components of the big reference ontology.
Sorry, Farhad, the online, they don't see your presentation anymore.
Okay, Arco. Thank you.
The presentation is not seen anymore by people on the outside.
I got stuck.
Okay, you're good. They want to see your solar system.
Yeah, my solar system.
Go back, repeat this about it.
Record again. But anyway, so let's go back to reality. So okay, so there are two main categories. There are 112 classes under continuance and 34 classes under coherence. That's the entire supply chain ontology right now. So things like object, functions, agents, location, they're under continuance. Things like processes, services, events, temporal regions are under coherence. I'll try to be faster. So from here on, I'll use some diagrams. So the green box is BFO, the gray box is IF4, and chain. So retailer is we deal with, and also traceable resource unit, including load, lot, and shipment. These are type of roles that we care about in supply chain. In terms of processes, for example, logistics services and manufacturing services are types of commercial services we have, or packaging process, receiving process, dispatch process. These are the type of processes that we care about. And there are all subtype of business process, which is a subtype of plan process in IF. And here are some immaterial entities, for example, site and location, ship from location, ship to location, or we have a bunch of three-dimensional spatial region like airway, seaway, shipping route. These are some of the entities under immaterial entity. Just give you an idea of some of the core classes. For example, business organization is one of the core classes in supply chain that has functions. So we decided to separate business function from artifact function. So and you can see the semi-formal definition of business function here. On supplier and supplier role. So basically, any business organization or person that has a supplier role is actually equivalent to a supplier. And then we have the definition of supplier role here. Basically, it's not definition, it's a necessary condition, right? So we are basically not going to define it yet. Supply chain system itself is a type of engineered system which is prescribed by some supply chain plan specification, and as part has some group of suppliers, and a supplier is a member of that group. So that aggregation should be maintained throughout the structure and the model. For example, if that's a partial view of the Ford Motor supply chain, for example, Continental sells powertrain assembly to Ford. So these are all organizations. But the relationship between these organizations, we try to use the relators structure because OWL cannot take care of multi-place relationships properly. So we are using supply chain relationship as a type of relational C that, for example, here we have supplier, buyer, and product. That's how it mediates between these three roles, which is founded by a foundational event. So that's our strategy for addressing those type of relationships. Location, so some locations should be modeled as roles. For example, location role is a role, basically is a type of geospatial site that is location of some material entity or site of some process. That's how we define a location role. So I'll give you examples of location role. For example, supply chain node role is equivalent to a location role, which is role of a geospatial site, which is a site of a supply chain process. So, and that's a defined class, and we can see the FOL axiom. So in that way, we are using rolification for representing locations. And identifier, that's something we need a lot in all IOF working groups. So the way right now we have modeled it is modeled it as an information content entity. There are three different types of identifier: arbitrary name and code identifier. For example, Nike's code is a type of code identifier which designates a business process. And you can see, for example, Coca-Cola company is diagnosed is designated by this code, which is basically a designation of function. The function is soft drink manufacturing function. So in that way, we are using.
Is it Nike's code is identifier or classifier?
It's a classifier.
Yeah, but the code itself, the five digit itself is regarded as
It's a code,
as a code.
not an identifier. You know, we do have in the Commons library from OMG
Okay.
a couple of different identifiers and codes models taken from ISO 11179.
Mm-hmm.
And I would be happy to share that with you.
Yeah,
You could
absolutely.
use those to replace what you have.
Exactly, because that's the area that needs a lot of attention. So
And they work for the substance codes and substance identifiers, and also for naming. We have a pattern for that.
okay.
It allows you to do conceptual naming,
Mhm.
and with a context, and that context could be a jurisdiction, could be a validation window, all that kind of stuff. So if you would like those ontologies, send me email.
There you go. That's the plan, because this pattern is something that we need to have. We don't have that in
Yeah.
And in fact, we did a lot of work with that for FIBO, and then we extracted the FIBO model into its standalone one,
Okay.
so that you don't have to inherit all of FIBO to get that.
Oh, nice. Yeah, I need to talk to you about that
Yeah,
for sure.
yeah, send me an email.
Sure. So okay, class annotation. That's something basic. Well,
2 minutes.
2 minutes. All right. Yes.
Sorry.
Tit for tat. Yeah. So this is something that Will actually has done with the architecture panel group, and just give you a quick overview of the process. So we should start with natural language definition. Basically, that's a required annotation for all classes. We need to label them, specify necessary alternative labels, either acronym, symbol, or synonym. And then, so in the next stage, if it is primitive, the primitive term is a term that for which we cannot have necessary and sufficient condition. It's either necessary or sufficient, or it's so basic, like process, we can never properly define, give axioms for that. If it is a primitive, then we should basically define logic axiom, either first order logic axiom or semi-formal natural language axiom, and we should pair them together. For example, here you can see an example of pairing. That's definition of factory. So you define under a logic axiom the first order logic axiom and semi-formal natural language. And then if it is not a primitive, then you should have necessary and sufficient condition, right? And through basically the right
So
annotation
do we
properties.
define, can you go back to previous slide? So do we define, I mean, well, no question for you, but maybe for Will and other people. So for primitives, we define logic axiom.
For
Yeah.
yes, for primitives we
We
have
do.
logic axiom because we cannot have definition, right? So,
Optional.
and it's optional.
It is,
Yeah,
yes.
if we can, it would be useful if we can provide some axioms. Okay, I'll quickly go through the slides, and then it's always useful to provide examples and additional annotations, including editorial note, explanatory note, things like that. So, and then we have some supporting documents under Confluence for each envisioned sub-ontology. There is a page with some description of the content and the goal and class structure. We have a glossary of terms with all natural language definitions. So if you want to comment on those, you are more than welcome to actually access the glossary of terms. It's already published on Confluence. In terms of challenges, well, we have so many mid-level constructs missing still, right? So locations, identifier, these are the things that we are missing. Partitioning and architecture, changing the architecture of the ontology, more consistent design patterns, and also we don't have really a clear set of requirements for a reference ontology. We keep saying reference ontology, but it's kind of not very clear that what exactly is meant by reference ontology here. So we need to work on that. And next step is to basically release the beta version in a few weeks, hopefully, and then test and validate the ontology using more real data. Yeah, and some publication. And yeah, so I'll stop here. Okay.
Thank you.
On time.
Question?
Yeah.
So far, do you think in the supply chain, there's a notion of supply chain design also? I know that we have plan and execution and perhaps also like we realize.
Yeah, I mean, you don't need to design every supply chain, but there are some cases that we design a supply chain, right? So sometimes they happen, they on the fly, they are built. You don't intentionally go and design your supply chain. In that situation, yeah, you don't have the design process. But there are some cases that you say, okay, let's spend 2 weeks designing a supply chain, right? So that happens. It exists.
Related question, what about optimizing?
Oh yeah,
Are we talking about optimization? I mean, I'm going back to my case to scheduling. We didn't address that at all. Probably same applies.
Yeah, we are not
supply
even
chain.
there. Yeah, we are not even close to optimization. That's definitely an issue. Question?
Yeah. Does SCRO covers the logistic and transport chain?
Oh yeah,
Up to what extent? Like the standard defined by IATA 1 record and DCSA standard, all those are incorporated in SCR?
Well, we try to use existing standards when we are defining classes. We don't want to reinvent the wheel. So we go over all the standards and check their semantics and try to make sure we can kind of merge them together and give a definition that agrees with all of them. I cannot claim that we have checked all existing standards in logistics, but we do our best to cover like GS1, APIX. We definitely check those standards before creating any term.
And like supply chain deals with, it incorporates flow of information, money, and material. So that SCRO covers all 3 dimensions of the flow.
Well, right now, the easiest one is flow of material. We have addressed that, but yeah, information is next, and money maybe it's already taken care of through FIBO, the flow of cash, right, between partners. So
We have a lot of relationships. I don't know if we have.
Oh, I think I think you have to have like invoice and payment.
yeah, eventually we need to
Those
go
should be
there.
in your.
Yeah, that's going to be huge anyway. But yeah.
There is work going on in the OMG retail community
Hmm.
that might have some things that are useful to
Okay.
do there as well. I think they're starting with digital receipts
Okay.
and their fiscal APIs for point of sale, point of service systems. So I don't know exactly when their stuff will be publicly available,
Okay.
but they do have some relationships that might be useful. And we also have patterns for parties and the situations in which they play roles
Okay.
that are a little more sophisticated in the Commons ontologies.
Okay. Great.
Those are not yet publicly available, but hopefully by the end of the year, but I can share the current version.
Yeah, that would be very useful. All right.
I think in the next round, but I think we should try and look at the wages and
Mhm,
try to ontologize some of the wages message, like
Yeah, I'd be happy.
the purchase order, shipment status.
Yeah,
Um,
if you help me with that, yeah, for sure. So
Yeah,
I
he's
guess
doing all the work, he's.
I have one more question, like, is there any jail use case, someone using this SCRO?
Well, no, because it
Any-
has not
no?
been released yet. So we use internal use cases
Okay.
to define the scope of the ontology and to validate it. But hopefully, after the beta version is released, we'll get some more.
Okay, so the further question I have is like logistic chain especially deals with like stakeholders like trucker, freight forwarder.
Mhm.
Those guys are like they are not going to follow the standard, say location code, United Nations location code. So if we have a data platform based on these standards like SCRO ontology, then how we are going to ingest the data coming from the tracker, because they are going to send the data in their own way.
Yeah, if we don't have data, we don't have data, right? But if we have, then we should be able to map it to the ontology, right? So I don't have a good answer for that. Yeah, but I agree that those truckers don't follow any standard. Maybe they have their own basic system. Yeah, so maybe it's more applicable to larger supply chain, more digitized and automated supply chains, not those fragmented manual ones. Yeah, maybe. But yeah, there are lots of things.
these trucks, they usually send it to like a portal. So, there could be a system behind the portal, right, that converts truck messages into ontology. If companies want to use ontology for their
Yeah.
purpose.
Like
to
creating an application oriented ontology to convert, to map the data into standards.
Yeah.
So I guess
Some
you're
comment from Jim online, or maybe you already addressed it.
Jim, more stable if you turned off. Okay.
No. Yeah, some
The
comment.
idea of annotation flowchart. Incorporate into annotation policy. Well, yeah, that's the plan, right? So we real maybe, but it's not like a normative, right? It's just a guidance. So, but
Well, yeah, so the annotation vocabulary itself is going to be the norm very soon.
yeah, we can do that.
Yeah, but he said flow
Yeah.
chart that
Include the flowchart in
Farhad
that.
showed is actually very clearly shows what
Yeah,
should be
Let's
done.
do that.
I'll be going over that a little bit more this afternoon.
Oh, nice, great. So I guess we need to move on to the next presenter because we are already behind time. So yeah, next presenter is Fernando Mas from Airbus, and I'll let him introduce the talk.
Yes, okay, thank you. Thanks, Marco. Good morning. My name is Fernando Mas. I will present this paper, Enhanced Metamodel Approach Supporting Models for Manufacturing Methodology, on behalf of my authors. And thanks to Dusan and to Farhad to let me to present today, because my original day was Monday, but unfortunately on Monday I was traveling to be here. Okay. I will present on behalf of my authors, and basically I will speak about an introduction, I will tell you something about the models for manufacturing methodology and some highlights about the meta models and the industrial applications. And after pass through the different meta models that we have defined, ending with the conclusion of the paper. I will try to also to save some time. Okay.
Thank you.
Okay, what's model for manufacturing? Models for manufacturing was a methodology that we started in 2017 in a research group between University of Sevilla, Airbus, and M&M Group. And it's a methodology that aims to be an ontology-based engineering methodology, okay? We are not speaking on ontology in terms of classification of data. We are trying to speak ontologies in the field of capture the knowledge, and especially on the field of manufacturing, and especially on the field of aerospace industry. To define not only data, we aim to define also functions, behavior of the systems, and semantic in order to be interoperable with other systems, okay? The concept of model-based is behind of that, of course, but applied to other fields of industry, in this case to manufacturing and assembly. And what we like is to enable more robust engineering and to pass from the document to the model, okay, from the 3D and all things around the PLM and CAD to the model. We have published several articles, several papers, and several reviews. We have made some industrial use cases and non-industrial use cases that you can see there, and you can read if you want to know some more, okay? What is the methodology? Methodology is a methodology based on three layers framework. We expect to have on the lower layer all the information coming from other systems, coming from our own definitions, coming from documents. This is a big data lake where information is. We don't like to replace any software. We will have on the service layer simulation tools, CAD modelers, design space analysis, dashboards, all the software tools. But we expect to define the intermediate layer, that we name it the ontology layer, where the models live and where the company IP is defined. We have defined 4 different models. One is the scope model that try to give an umbrella of the other models and to say what is in, what is out. It says process planning that is a really big field, and sometimes to make use cases and examples, you need to say what is inside the system, what is outside the system, and to define the main capabilities, the main functions, and the main data, okay? And after the scope model that drives the other models, we have the data model that is the definition of all the information, the behavioral model that define how the system works, and the semantics model that define how to define data for interoperability with other applications. Okay, the flow is very simple because the flow is data models define the data, also define how the modelers use this data. Behavior model define the different services that are needed, can be in the market, can be developed for your own system, okay? And the semantic model is the way on how to access to the databases, to the existing databases in order to be coherent and interoperability with the other systems. The methodology has 3 golden rules. The first one is we define a set of meta models. We are not linked with any software. We are agnostic to any software. This is the reason of this paper, to define this meta model. Any software that cover this meta model can be used for the methodology. We are not promoting any software. And the methodology also promotes a MLM system, a model lifecycle management system. Is similar to a PLM system, but to manage models instead to manage CAD files. This is especially interesting when you have in a collaborative way, and you need to have versions, configuration, life cycles, and so. Okay, this is already done on the market, and this is just to apply PLM systems to models. Okay, why meta models? Meta models is because we want to be agnostic from the software. We want to say this is the meta models to build our ontology, and after that you can select any software that fit with the meta model can be used. Why meta model? You have the definition of the meta model of date, okay, and you can apply to birth date, okay, fixed date, and also the artifact is birth date, okay. This was really interesting from the very beginning, and we tried, based on our use cases, to launch a set of meta models in order to let the people that was using the use case to use any software. Also to let to the people that is helping us to develop the MLM to be interoperative with the different softwares. We launched the first version of the meta models based on all these industrial applications that we have developed, okay, that you can find on the paper on the different references. And this meta model started to work, but we discover 1 year after using them that need to be improved, because there are some things that doesn't work. There are some other things that we forget to add. And this is a second version of our first attempt of the meta models to fulfill better our methodology. Okay, you can see here some examples of the applications that you can read on the references. Okay, and this is a set of different softwares that we are using today to develop these ontologies that fits our meta models. We are using either Zero from Ramus, we are using Concept Maps from Concept Maps tool, we are using Dot, we are using Excel. All these tools can be used, and you can select others if the meta models are covered by them. Okay, why we want to enhance the previous release of these meta models? Because we have found issues on the practical application, of course. It was just a first attempt to do these meta models. We in the first version we were maybe more complicated. We try to simplify in this version. We remove some abstract classes that we have defined before that are not needed on the practical use. Okay. We have also redefined or refined the relationship and cardinality. Okay, this is a definition of the models. Okay, we have adapted to the MOF standards. Okay, in order to have meta models based on a standard, we include all the concepts and relationship on the ontology ladder. In the first attempt of the meta model, we haven't a semantic model. We have included the semantic model and 2 more models that I will explain after. Okay. Today we have 70 classes in 5 packages that cover the scope model, the data model, the behavior model, the semantic model, and we have included a new class of the model lifecycle management model in order to have a cover to apply this model lifecycle management. And we include there another concept coming from the PLM that is the library. Okay, we want to have the reuse of the parts of our ontology or the inclusion of ontologies defined outside. Okay. Okay. Basically, the scope meta model that I said before that represent the main function that are relationship of the system. This was the previous model. I will not enter in details in this presentation. You have the paper, okay, but this was the first attempt of the model. We have simplified to that. We have refined the cardinalities. And as an example, we are using today IDE0, Rambus IDE0 to cover this kind of models. And the IDE0 model is covered by the scope meta model. But you can use any other system, okay? Data meta model represent the data on the system. We have simplified also a little bit, and we have removed some classes that we are not used on the practice. And this is an example. Today we are using CMAP. That is a very simple application. And the CMAP model fitted the meta model. That means that we can use that. Also, some other systems that can have a model that fits with the meta model. Okay. Behavior model. This is one of the most important models because it's who represent the behavior of the system, how the system works, and all the relationship between the different activities and the different tasks, and of course the data flow. We have also redefined the meta model. I insist the details on the paper. I will not be inside here, but we are using GraphBiff.dot as a software tool, and the model fit also the meta model. You can see all these examples in detail on the references on our publications about the different use cases. Also, semantic meta model previously was just a box. It's more detailed now. It's the way where models for manufacturing can read the other databases that are existing. I am not speaking about IT interface. IT interface is out of our scope. Okay, I don't know if you need to access a PDF. I don't know how to access from the IT point of view. But of course, the information that is on the PDF can be read and can be understood by the definition of the ontology through the semantics. Okay. We are trying also to integrate semantics coming from standards because they're in materials or in metric data system, and so there are out of standards that can be integrated easily. We are today using an Excel file, okay, but can be replaced by a simple text file. And this is the new in this development is the library that try to accommodate all the information that can be reused on the ontologies that has been defined before. And you can use, like in a CAD system, you can use as is, or you can use as your first step, and you can modify to incorporate on your model, okay? And the MLM, that is just a container in order to facilitate to the people that is working, integrating the PLM. We are using ARAS as a use case to contain models and to build all the data flows and all the ownerships and all the configuration versions, and so in order to let a collaborative work around models using the methodology. Okay, and to finish, discussion of this work is the reason to change. The reason to change was meta model was based on the first attempts of our work on the use cases, but after to work more and more on other use cases and with other people, we found that meta models need a refination and sometimes a simplification. We also adapted the MOF standard. We simplified the UML class diagrams. And the library concept, I think, is a new element that will help us to reuse information. Okay. Now we are focused on the development of a prototype to build the 3 layers in order to simulate all the process and to check on the real use case these meta models with the tools. And this is basically what I would like to show to you. Merci beaucoup. And have a good day.
Question. So are you using the CCM for this to generate your ontologies from the network?
No.
You're doing it by hand?
We are doing today by hand. By hand, we are using different tools for the different models of the ontology.
Yeah.
And the only thing that we are today more or less automatically is that we have some interfaces for these particular tools to split the models in objects and to guarantee that in the MLM that we are using ARAS, all is coherent.
Yeah.
And all flows between the people that is working coherent with birth. Against the meta models, all these things. We are a little group.
So there are some automated tools, or at least standards from OMG for going from a meta model to OWL. The OWL is messy, but it's a start. So if you were interested in that, Rebecca has my contact details, or you can reach out to me.
Yeah, Rebecca is part of our group.
Yeah. And that I've worked with a lot at OMG, his name is Pete Ribbett. And Pete built, again, it's ugly, but it starts from your meta model, so you don't lose any information at all. The only thing is, as well as the association, they are named, so you get a bunch of extra stuff. But it's still a starting point.
Okay, I appreciate it a lot.
Yeah.
Thank you.
You're welcome.
Thank you.
Other questions? Let's check if we have. I have a question from online. It says, how do you spread the ontology within the organization, and are there any particular challenges? Fernando.
I'm sorry.
Question online.
I'm sorry.
Yeah. How do you spread the ontology within the organization? How do you deploy?
Yeah, the idea is exactly. Maybe I can speak here. No? Yeah. The idea is to use the MLM as the tool that can be used to consult the different models and consult the different ontologies and let the people in the organization to perform modifications or to reuse part of the ontologies in a controlled environment. Okay.
And are there any challenges doing that?
No, because we are starting now with an MLM and it's used just on the research group, and everyone is agree each other that works. So we need to spread outside the research group in order to use, and this is not the case today.
Okay, Oliver, I think you get answer.
That's okay.
Yeah.
Okay.
Go ahead.
We can move on to the next presentation. Thank you.
Thank you,
Fernando.
Thank you.
So this paper is titled Sorting Products Systems Over the Operational Life. So it's kind of extension of products your domain, which is great. So we are honored to have 2 services right after this presentation. So if you're interested, that's the topic that you want to be here for right after the presentation.
Oh my goodness, I'm not on the first slide. That's terribly embarrassing. Sorry. Hi, I thought I had everything set up properly and then realized that I didn't. This is some work that Oliver, I have been doing, and we've had some help from one of our master students called Peter Dobber, but it's a real problem that we've seen over a long time in supply chains around product service systems. It's different to product. And there are some real big challenges here. And I think it's kind of akin to some of those things that we're seeing with some of the systems where they don't quite meet up because really things are a little bit different with them from time to time. So what am I here for? I want to explain some of the long-term supply chain challenges and issues that we face with what I'm going to call just product support. I don't like the word product support or aftermarket. It's where I used to make all the money. So it's not something I'm too keen on. I want to define them within the context of a product service system and then identify where value can accrue during its life so we can begin to improve things and overcome challenges that we've got. This is really just to start the discussion off because Oliver and I felt that the literature here was actually quite weak and that we needed to improve the theoretical understanding based on some of the pain that we've seen with some of the firms. I'll be honest, this is my big problem, my big nightmare. I do have an iMac at home and I did have to replace the memory and the guys told me it's quite old. I've actually got something here which is a very old iPod and they told me that was an antique. Yeah, but it still works. The Unix box I have downstairs, I have exactly the same problem. Now, how do I support something that's 13 years old? And I think that really begins to show what some of the problems are with these product service systems. They last a lot longer. People keep them and things change. My machine may no longer be supported by the OEM. And this is really a problem that we've seen in transport and in medical equipment. People still use it. On a more academic basis, rather than me complaining about not being able to get spares for my machine, we've got 4 papers from the team that we've looked at. The review on upgradability has been really useful as a starting point with the Journal of Clean Production. It takes a different approach to circular economy and really how do we keep upgrading equipment? I'm talking about longer life equipment, not my iPhone that I have here. The other one below it, midlife upgrades of capital equipment. I think that's because we're getting older. How do I stop the grey hairs showing? That's pretty much what it's saying. How do I keep the performance or enhance the performance? A new one that we've just had published in production planning and control equipment upgrade services, drivers' capabilities, resources. And I think this is where we're really trying to get to the nub of the problem. What makes us do this? I've also seen problems with manufacturers saying, no, we'll sell them a new one rather than the old one. And this is, I think, a mentality shift that we have. I consider a lot of things really based around value and use. And this paper here came about, we were changing transformers within a system on railway trains, and the footprint was really the issue that we had to face. And we didn't really need to improve the performance of an air-cooled transformer because it really hasn't changed in 40 years. Insulation's a bit better, yeah, so what? They just needed a solution for what they've got, and the OEM wouldn't provide them with any because they'd stopped making it 35 years ago. The bottom one is one which we've just published through Frontiers, nested life cycles. And I think this is going to become a bigger and bigger problem with all of this. As we integrate digital into this, we suddenly discover that digital guys think, oh, 3 years makes it old, 5 years makes it really old, 7 years, oh, I don't even remember that. Nested life cycles within systems, and we need a way to be actually link these subsystems and subsystems, I think. Because on an asset management basis, it becomes an absolute nightmare. And that's really the discussion that we have. interesting, during the peer review, we had some arguments over, oh, this problem's all been fixed. And I went back to some of the interviews that we had, and they said, no, it hasn't been fixed. We're struggling with it more and more. I'm going to go back and just have a quick look at product service system. I've got a picture of a wind turbine there. Good product service system. And I wanted to go back to a simple definition of it. Why did I want to do that? I wanted to make sure that we were being really clear on what we were considering a product service system here. And I want to put it in industrial context. So I'm bounding it there, because I think they're a little bit different to my handy little iPhone, which is my friend and saves my life on a regular basis. What happens? This is Demetrius was talking about the ontology for the Lifecycle, and I've taken it and I've turned it into a visual because I prefer pictures to words. Got a simple question here. Who sets the end of life? I don't know. Sometimes it's you, sometimes it's me, sometimes it's somebody else. But we do have distinct phases in there. And I'm trying to show here that the middle of life is really much longer than the beginning of life. And the end of life is really quite short. It's decommissioned, bang. Takes a relatively short period of time. That middle of life is really, really critical because that's where the equipment really is used for value creation. And I'll be honest, for waste creation, pollution creation and emissions, this is where we create a lot of the environmental mess that we have. But that's often designed in at the beginning of life. We design and build the product, and then we have to support it until it's decommissioned. And a good colleague of mine, we were arguing who takes the, I'm going to say traditional phase out word, I don't like it. Who takes the decommissioning? Who says we're no longer going to support it? And I think that is something, what do we mean by those words as well? It's a really difficult language there. I was having an argument with a healthcare company and I said, where the heck do you get your 7 years from? So I actually Googled it, and we support aftermarket for 7 years after the last machine is made. Again, I need clear definitions what they mean there. Is that the end of the series or is that the last of that type? I think that's really important. 7 years seems to be becoming quite a common term. Apple tell me 5 years. I've got my Mac downstairs, which is 13 years. So really, I think we've got to get what is it we want. Now here in this document, and I've taken it from the European Commission, they set some rules. Manufacturers must be able to assure delivery within 15 days. Well, that's quite challenging sometimes, particularly given the supply chain challenges we have now. And suddenly we're beginning to see the issues that we have. Do I hold stock? Who holds stock? Where is the stock? Very, very simple things, but this is really critical within your ERP system and your PLM system. This creates some great challenges for me. It's not easy, particularly when we have digital combined with traditional mechanical stuff. And I want to ask, what is reasonable and economic for aftermarket support? Really simple question. I don't know the answer. I have a student looking at that for me at the moment, and I think it's really, really important. And we're doing some studies on this with Sangal at the moment. And I think it's really important that we understand this. Siemens got it, Siemens Gamsa, with wind turbines. Original design life, and they say design life, 20 years, and then with an upgrade, we'll push it to 25 years. There are some good examples, but who is responsible for the product lifespan? I'm using the word here, and again, we're coming back to ontologies. Lifespan, what do I mean by that? And I'm going to be quite harsh. I don't believe that the OEM can define what the life cycle is. They cannot define the lifespan. They can tell me when they're going to stop making the car, plane, train, automobile, or whatever, but they can't tell me when I'm going to stop using it. And I think that's quite an interesting thing. Thomas, one of my PhD students, he said, but we've got things that we have to look after which are 75 years old. Wow. How do we keep these working? So what am I looking at? I'm really looking at really long things. Ships. I've got a B-52 bomber there, power station, gas turbine, and a train. These create some quite extreme examples of product service systems here, where we need to be able to understand what is the supply chain that we have. And I'm going to focus now on the B52, because I think the B52 is great because there is so much publicly available documentation published by the US Department of Defense. And what I really, really like about it is it's got a beautiful introduce, produce, and withdraw curve. It's got a little bit of hump on the end, but who cares? 1952, it first flew. And 1954, they really started making the numbers. And you see it ramps up, introduction, mature, and withdraw curve. Brilliant. Little bit more about it. 20-year design life, kind of like the wind turbine. It's over 60 now, and it's probably going to get replanted with new engines. So it's going to go for about 90 years. That's kind of scary. That's like a Sopwith Camel is almost still working today. Designed for one mission. It went to low-level mission, cyber warfare, and all sorts of other stuff. So really changed. Now, if I go back and people sit there and say, please tell me what your requirements are. What are the needs of the customer? Complete mess. Because we could not foresee that at that time. Even using some of the foresight tools, we couldn't manage to do it. Technology around it has completely changed. My telephone now has more computing power than the B52 when it first came into life. How the heck do we support that? And that's an ongoing process of repair, replace, and upgrade. Very, very complicated. The other two dimensions, the environment, it's not alone. Other planes come and challenge it. The B-2 bomber is still not as cheap at delivering a ton of explosives. Russian systems came in, came out, coming back, I don't know. Different types of technology around it that could talk to it. We didn't really have digital when this thing first flew. Obsolescence, the computer system. The engines were actually obsolete pretty much from day one. The heating system, and it was pretty obsolete from day one because you either froze or you cooked. So they had lots of things to change. Interestingly, I've added people to obsolescence. The people that designed it are no longer here. The people that built it are no longer here. The skills, the technologies that we use to design and build this machine, no longer here. It's kind of like the pyramids. How the heck did we design and build this machine all that time ago? So what I'm saying here in reflection is that we need to consider the design life, design and make, and what happens. Our assumptions will be wrong. Let's live with that ambiguity. Our requirements will be wrong. We need optionality built into this, and we need to integrate that into the supply chain, because we've got a long-term support obligation here. And the B-52 is not a good example because the American government pours lots of money into it, but at what point do we not supporting? I saw an example where Siemens took a machine off the SAP system. PLM had killed it, and the next week, somebody said, could I have some spares? And they said, it's not in our system anymore. Really, really interesting. I also saw that in another way, another manufacturer in Zurich. They threw out the old machines that they used to make it, and they had to reverse engineer their own parts. I've also seen this with BAE Systems, where they're now moving from big volumes to small volumes. So they've moved from one manufacturing process, airplanes again, so the certification is very, very important, to using 3D printing because it's the only, it's the cheapest technology for making ones and twos of it. So really, how do we manage this? From the new build to the service market, how the heck do we manage it? It's not easy. We set the first places in place in the beginning. And I've put here, use phase 1, use phase 2, use phase 3. We do the repair, replace stuff all the way through. But we can reinvigorate this technology. We can consider it as a platform, which we keep adapting. Now, my question is, within the installed base, what is the installed base? Do we know what it is? Do we have it clearly documented? Do we understand what it actually looks like? How do we drive standardization? Why do I want to do that? It keeps out the competition. And it also allows me to get volume. And I need volume to be competitive against non-OEM vendors. What is the right duration that I should support? We saw earlier that there's some regulation coming in to suggest that 7 years should be about right. But really, is it? Does it make sense? I've read some stuff that says, well, it's about customer demand and requirements changing. Sometimes it's not. The technology is changing. So I can put technology in, particularly in a servitized environment, where I take value back out of it. And for me, the most important thing here is, how do I withdraw as support? The dynamics of the services are different to manufacturing. And I really think we need to understand a new approach here and how we put all this together. And I think we need to connect both parts, because it's almost like we have design and build that doesn't talk to services. Or if they do, they've got a supply chain which says, well, this is how we do it. Now you have to order the spares 12 months in advance, which really doesn't help service. I did actually hear of an interview where we had a controller say, couldn't you budget for that? It was an accidental failure on a machine. Cost a lot of money, and they wanted it budgeted 12 months in advance. So how do we link all those difficulties together? We tried to do this with a basic, simple model of what are the drivers which we've taken from our paper. And business options, I've taken that from marketing supply chain theory, like for like or like for better replacements. And then the challenges that we face in the service environment: small volumes, existing or new suppliers. Over 20 years, I can guarantee that half the suppliers will vanish. Great. Resources. Now, I really want to focus on supply chain and resources. Capabilities and competencies. That's people. Often forgotten in the supply chain. It's not just going to Amazon and ordering something and expecting it to turn up. Do we have the capabilities to actually program in something called Fortran when all the new guys are using something else? I don't know. We captured a whole load of issues here. How do we reverse engineer the spares? How do we then qualify them? How do we price? Pricing is terribly important. Where's the know-how? Know-how transfers from the OEM to the owner, operator, and the maintainer over its life cycle. How do we capture that again? How do we make sure that we know that we're talking about the same kind of things? Because we speak two different languages. So we can link that again, I think, with ontology. It's not a matter of just putting it on a screen. Do you have the machines to make the stuff with? Interchangeability between generations. I'm sitting here with a bunch of adapters. That's a USB to USB. Fantastic. Storage conditions, really basic stuff. If I buy some stuff and I put it in a warehouse, it could rust. It can degrade. So what happens? We still need the spares. Warranty from sub-suppliers. How do we manage that? I don't know how we manage that. Somebody just assumes that it's warranted by the supplier. Yeah, but I'm using a sub-supplier and I get stuck in the middle. How do we manage that? I don't know how we manage that. I don't think the systems are really sophisticated enough for us to do that, which is why when I go into my phones and the old computers, I use a grey market and I find stuff that I need. The product service system evolves with its life. My question, therefore, is how do suppliers deal with that evolution? It's not easy. Closing. Conclusions and recommendations. The traditional PLM model is far, far too simplistic. And we need a better model. And we need to keep that over the whole duration, the lifespan of the operational phase. And I really mean that. A lot of people think 7 years is a long time. I think it's yesterday. We've seen challenges from the B-52, and we have a lot of data now going through that. What is the real issues that we face? What happens? I think the extreme cases are really good learning, and we need some sort of unified decision model here to help us understand what's going on. I threw some stuff out there to try and build a model. A just decision support model is what we need. But it's got to have technical on one side, it's got to have commercial on the other. One of my best ways to say is you've got a small volume, so the prices are going to go up. And I hear manufacturers say, oh, we can't put the prices up. damn it, you better put the prices up, otherwise you're going to be losing money. What is best common practice today? I'm not generally sure, but I'm hoping I will by Christmas from my master thesis student. Supply chain aspects of product service systems really are poorly described. It's almost as if you can get them from the manufacturing division, and I don't think you can, particularly when you end up having to reverse engineer your own stuff. That's really interesting. Now, how do we wrap something around that so we actually know what we're talking about? We tried here to provide some insights to the challenges that exist. But what I'm calling here for is new research within the ontology so that we understand what it is we're talking about, and to create this model to support decision making. It's an empty sheet in some areas. There's a lot of things to build upon, and there's a lot of gaps, I think, between the tiles that we're looking at. Thank you very much. I just want to highlight the people that were doing the work, Oliver, Peter, and myself. If anybody wants to get interviewed by Peter during his master work, I would love to hear from you. Thank you very much. Now it's gone very quiet. I'm very worried I've been talking to myself. I don't hear you in the room because you're on mute. Ah.
Okay, how about now? Can you hear us?
Oh, I can hear you now. I had a panic for a minute that I'd spoken to myself for the last 15 minutes, and
Not, it was good
We're
presentation.
really enjoying your presentation, very thoughtful, yeah, ideas. Any question from the audience this time? Because, well, actually we can continue your presentation with the panel, which is basically you prepared us for the panel. We can maybe use the time to set up the layout. How do you want?
I'm very happy where I am right now.
Okay.
I'm quite happy where I am. Oh shoot!
So can you share?
Just a sec.
Okay, so then if they can hear you,
spot in the whole room.
and if they can hear you, right? I mean, you can stay there, right?
I don't know.
I don't think they can hear you.
Then maybe you can sit in the front row. How about
Yeah, I can come up front.
Yeah.
I'm
So.
just, kind
Oh,
of
come on,
joking.
you've got him out of his nice comfy seat at the back.
Yeah.
It's actually the coolest seat because there's a window.
Yeah.
Oh, that's why you disappeared from.
Well, no, I've been hiding by the window for this whole time.
Do you want? Okay. Yeah.
Are you going to tell me it's nice and warm in Tabs and that the food's really good? Because I don't want to hear that noise.
I don't usually associate nice and hot. That's a nice.
That's a problem in Texas, huh?
No, I don't do
Oh, yeah.
hot very well. I live in the Bay Area.
I know, we're
Oh,
weather
Bunch of
fans.
groups.
The area you have the same temperature here throughout.
Yeah, I mean, it doesn't get over 90 usually.
At home.
Yeah.
I mean, then
I can manage the camera if you talk with them.
Yeah, that's fine. I'll do it from here. Okay, so let's continue to our panel. The topic is industrial service systems and supply chain. I'm glad that Sean had some supply chain ideas and issues related to service systems. So it's very much aligned with this session. So the panelists are Dr. Sebastian Scholz, who's a senior researcher at ATB Bremen. Mr. William Sobel, who's a chief architect at MT Connect, and also a member at IOF. We just had a presentation from Dr. Sean West, who is a professor for product service innovation at the Lucerne University of Applied Sciences and Arts, and then Mr. Oliver Stowe, who is a research associate at Lucerne University. So, I mean, the panel is going to be very broadly related to product service system. There are two flavors of industrial services and manufacturing servitization. Yeah, that's the term that I cannot even pronounce it. Yeah, so one is product service systems, bundling products and services. The other side is to sell manufacturing capacity and capability as a service. So manufacturing as a service is also another aspect of that. So that's why this panel is kind of broadly covering both flavors of PSS, or in general, industrial services. And we have a few guiding questions, but we don't need to follow those questions necessarily. I try to just direct the conversation based on the interest and the direction of the discussions. I'll start with some very broad questions, and we can go into more detailed questions. And the questions are not targeted necessarily for any panelist. So maybe we'll start from the requirements, right? The question is, what are the requirements and the steps needed to transform from traditional like supply chains and production system to service-oriented PPS and manufacturing systems? So we can move on to discuss standards and ontologies at some point. But before going into standards and ontologies, just what are the general requirements that are needed to move towards a service-oriented architecture and in PSS and MAAS framework? So whoever wants to start. So the first question is again very generic. So I don't know, Will or Sebastian or Sean or.
I can start. I mean, we did some analysis of manufacturing as a service and what the top level requirements were. We looked at capability models for distributed manufacturing and on demand, and availability as the two sort of keys that are central axis that the thing revolved around. So if you could compose upward from the equipments, the people, the software, the technology that you had at the various different sites, and down to the individual machines and cells and so forth, all the way up to the enterprise level, then you can start getting a handle on where things could be done or how things could be completed, and then start making decisions using sort of a search methodology of just trying to find matching capabilities to the requirements coming out of the process engineering side of things. So breaking it down that way. But I mean, that was kind of a simple way of looking at it. We were looking at it's one area that we actually thought that ontologies would be an interesting approach, because we could describe the transitive relationships between the various different things. It was a nice graph-based problem set to try to solve, and lent itself well to this general domain, I thought.
So these requirements, our view is a little bit different, because we are often in contact with SME companies that are producing production lines or factories, and they see really a change, so that you have smaller lot sizes, increased let's say diversity of products that need to be manufactured on the production lines. So there's really a need to have this more flexible.
Yeah, of course, yeah, flexibility and the reconfigurability.
Yeah, and by this you need to reconfigure this, and this I think very much relates to these production planning and scheduling, because it's different whether you produce smaller lot sizes or bigger lot sizes.
Oh yeah, absolutely. Yeah. Great, thank you.
Can I just add to that? It's really interesting hearing that coming from a little bit north of here. We saw exactly the same in a made-to-order woodworking mill, and it's quite interesting. They were an extreme single-piece flow, and everything had to go into the container in reverse order. So when you got to site, it was installed in the correct order. And during the COVID phase that we had, a lot of people went off sick. and actually trying to match the production capabilities that you had in terms of machines and people and to a schedule was actually quite difficult for them. And we supported them to create a scheduler because it became quite challenging. And I think what we realized, Simon and I, when we were doing that work, was considering it as a service. The production process actually gave us a lot more flexibility rather than just trying to maximize it to OEE, which during COVID was kind of a random number at one point.
Yeah, OEE is often a random number.
So Oliver, do you have anything to add, or you can move on?
Yeah, if I may add, when transitioning from being a product seller to being a product service systems provider or service vendor, we have a lot of theory on the organizational and strategic level, which is within the domain of servitization. So we have some distinct challenges there within the PSS research community, which could be seen as a subdomain of servitization. The answers are often, it depends. Manufacturing as a service, I think the most important part there is that the organization have to try and redefine value, because the value is not going to be the price tag on the product anymore. Rather, the value is going to be the capabilities they have in order to turn a piece of metal into a shiny car, for example. And putting price tags on that is way more complicated. It requires a lot of good relationships with the so-called customers. It's about building trust, and so therefore, yes, capability models are very well suited as an alternative. I also could propose, for example, service dominant logic, which has been how shall I say, criticized by the technical domains and the PSS community in terms of defining value. Yet within the consumer sector, they have it's very well accepted. A large body of literature is starting to emerge. And what is specifically interesting is when it comes to digital and networks, which kind of are the enablers of services. It is a model that works very well. So maybe that could be some considerations as well when it comes to requirements for transitioning.
Yeah, I agree. Capabilities is a critical factor here. And in fact, there is a panel in the afternoon about capabilities. So you're kind of setting the stage for that. If you're interested, I recommend you to attend that panel. Okay, moving on. So to the next question, which is more about how we gain visibility. Because when we are in the context of a PSS, we need to collect data real time from product while they are being used by the customer, by the user, and such that we can provide service in a timely fashion, the quality they expect. But obviously, there are lots of challenges here. So let's discuss those challenges and what are missing, what are the pieces of puzzle that are missing for collecting real-time data from customer while they're using the product. So starting from in person, like Neil or Sebastian?
Yeah, I think we have to split this into several options. Am I an end user using a product? Do we want to include this? Because this opens up another dimension. Just imagine a car. Getting data out of a car is easy, but is it allowed because I'm the car? And shall this go back to the manufacturing process? So I think this is a complete different dimension and maybe too much for this discussion. But if you're in a factory, at least I know in process industry, it's quite common that you log everything in the central system. So I think in this sense, it's more or less state of the art. What's different is if, for example, you are a provider of a machine, and this machine is used in several customers, so that you can collect the data from all your installations and try to make some assumptions over the group of machines. I think that's something where we have to do some work on how this, in Europe it's with this, what's called, now I'm just having the German word, Datenschutzgrundverordnung.
Yeah, GDP.
GDPR, sorry.
No, GDPR.
I was thinking on the German version of it. We have the GDPR, so that this is all compliant. But I think we really have to take care that we are not opening up the full dimension.
And I guess sort of to jump to one of the topics I brought up before, or brought with you prior, was to look at this from sort of a more outcome-based economic model. So if you kind of flip the whole thing over, and the OEM is responsible for providing the outcome. There's already done tooling. I mean, a lot of companies buy tools not by the tool, but by the hole. So you'll buy, 1,000 holes. And the vendor will then supply you with enough tools to be able to make 1,000 holes. Now, of course, they often in a large shop, what they'll do is not just supply you with the tools, but they'll also supply you with a human being who will be there to monitor how you use those tools, because if you're too light on your metal removal rates, you're going to be wearing the tools too quickly. If you're too fast, you're going to break your tools. That's going to obviously blow out the economic model for the OEM. So there has to be a way to be able to verify that you're using the tools properly and getting the maximum output from those tools, so that everybody gets shared benefit. It's also the shared benefit models. So when you start going into shared benefit, shared outcome, then you start getting into then we have to be able to monitor and collect information so that the economic model even works. So you can trust somebody to do something right, but you have to be able to verify it. And I think that we have feedback now from the manufacturing systems, and other systems are starting to give us more feedback. Rolls-Royce has a fly-by-the-hour model, and Total Care is what they're selling now. GE has a similar program. These kind of models require that. It's interesting. Also, it changes the strategy for the designer, because they're now responsible for all the maintenance. They're responsible for the use of that product. Therefore, they want to have the optimal efficiency of that product to be able to get the most return. It's the only way they can make profit on top of the cost, because there's no lease. I mean, there's a lot of examples out there. So I think if we go into any of those economic models, where I see sort of the service industry going, the shared economy going, we're going to have to go back to what your question was, we're going to have that feedback from systems along the entire life cycle, manufacturing, all the way from design through end of life, because it's going to be the OEM responsibility to make that the most efficient possible, where they can't sort of now put that off on the customer to support that life cycle.
Okay, great, thank you. Sean?
I'm going to make a counter view. I don't understand the assumption of why it has to be the OEM.
Yeah.
That's my first major assumption. And I used to work for GE, so I was the OEM, and then I went for another company where we weren't the OEM. I think that's something that we have to. Somebody is responsible for the output of whatever you're producing, and I agree with that completely. I don't agree with the fact that we're never going to capture this data in places like Germany, because we already have phones in there and everything. I think there's a different way that we approach the problem of people using tools, I say incorrectly. Using data as a policeman, you can use it once or twice, at which point I will cut the tether and I will go back to a different model. Power by the hour was used before we had computers, when it first came out. So I think there's some aspects. When we come back to the tool machine, if I'm using the wrong mix of tools and equipment and machines. How do we get the system to advise me of what I should be using? And I've seen some really cool stuff at the moment coming out of Bossard of basically an automated tool coming through. I think we've also got to take a step back and say, well, what if we can't capture the data all the way through it real time? How do we manage things? And what do we need to manage? And I think we have to deal with that in terms of, do we get 20 milliseconds or every half an hour in terms of data flows? Oh, something went very strange on my screen for a minute.
Can I add
You have
to
your
you, Sean?
Yeah, sure.
Yep.
Yeah, well, I agree with the multiple views. I think it comes down to what basically paid my PhD, which were projects of medium size but also large firms approaching us and asking us, how do we create value from the data that we have collected? So there has been this hype on big data and so on and so forth. So organizations started collecting data because it was the big promise that it will solve all their problems. Now they are currently realizing that data which is not analyzed, processed into informations, and the informations are not used in order to make better decisions, it's completely worthless. Now, so first of all, the assumption you have to collect all the data, it's just wrong. It's just a cost. If you don't have an idea on what you are going to do, what you want to do with the data, don't collect it. So first develop the idea. Once you develop the idea, you start to see the benefits and risks, and you are able to explain the benefits and risks to your customer, potentially to the machine he's using, and you want to collect the data from. So if you, for example, approach me and you ask me, okay, can you collect the data from your machine? I ask you, yeah, but why? What do you need it for? And if you then don't have good answers, then you will have troubles being able to collect the data. So this is the first point, and the second point is there are multiple different modes and compositions of how one can create value with data. You can also create value with data on closed systems, because there some manufacturers are not willing to connect, for example, their manufacturing plant to an outside network. So they keep data collection and analytical tools within the factories, which can be perfectly fine. They can develop value as well, but you really have to be clear on why you are collecting data, not just go and collect every little millisecond from every machine that you have without knowing what you want to do with it. That's my perspective.
Yeah, I mean, I'll give a counter to that because I ran an analytics company for quite a while. And often when you're starting out and you're doing data collection, you don't know what you need. You haven't built your models yet. You don't know what is going to be highly correlated with whatever the outcome that you want to achieve. So overcommitting on data, I don't think is a problem. I think not curating the data correctly is a problem. And I mean, there are methodologies for being able to create like classification of intervals and things along that line that can properly contextualize the data within the business process or within the operational states of the machine, which then help you to understand what was going on at certain periods of time. Now, you don't have to just throw out everything that you're not currently using because you don't currently know what you're going to do with it. You can keep that. Storage isn't really that expensive. Curation, just dumping it into like a unstructured data lake is a disaster. So there's a series of transformations you have to make to the data to make it even usable. You have to bring the semantics and meaning and context into it so that you properly store it, and then you can pass it into the analytics. And then you can start using it and building your models and doing things like we did a lot of like k-means, and we did some machine learning to be able to do some regressions on. Again, machine learning isn't the be all and end all. It often just gives you clusters and some regressions, but it does allow you to build some of the rules. If you have like a complex event processing or other types of analytical infrastructure, you can start to derive value out of it. Again, you're building this corpus of information that then you can drive more your models and try to get some economies of scale across multiple different customers and across multiple different processes. And that's that's kind of the trick, but you have to be able to do the correct association and contextualization of it.
Well, I agree on the data storage that is not the most expensive thing, but if you start fitting sensors and hardware to your products, and you put a lot of resources in, first of all, convincing the customer that he buys the module, convincing the customer that he shares the data with you without having a plan on what you are going to do with it, at least on a strategic level, just for analysis purpose. If it would be my company, I wouldn't invest in it.
Yeah, so I would agree with that. The sensor, just sticking random sensors on, not brilliant. But I mean, you can just get just the data you can get out of the control systems on, like I'm talking about discrete manufacturing equipment and even heat treat and other types of processes around manufacturing. You can get a lot of data out of the control systems to be able to drive the initial analytics that you're doing.
No, I agree. I think adding sensors without sense makes no sense. The only thing what you should foresee is, the only thing what you should foresee in the architecture is that in case you add a sensor, that your APIs or whatever can transport the data.
That's kind of embarrassing if you can't transport the data. We had the benefit 20 years ago of tagging up power stations. And there we had a limit of about 1,000 tags for cost. So we pulled data out of the SCADA as much as we could. And once in a while, we would put additional sensors on it, on critical things, as an asset owner, not as the OEM. And it was kind of interesting seeing the pushback at that point with the OEM saying, "Oh, you don't need any of these." There was a mentality of machine protection versus performance optimization. And I think that's to me is an important stage that we have to take. We're trying to get asset improvement now, I think, through this, more performance out of it, more outcome. And we suddenly begin to learn that the designers were really, really conservative in some areas, and in other areas they had absolutely no idea what they were doing, and they made huge errors. And I think over the time, we need that contextual data. We need to be able to get the AI in there to understand really what's going on and to flush out the contextual data, which is really important. And then I think we begin to get somewhere where we can build up a proper model of what the heck is going on.
I agree with that.
Yeah, so we are approaching towards the end of the panel, but as a closing question, so let's move on to the main topic of this conference, which is ontologies and standards. Let's have a 1-minute response on that question. So what's the role of ontologies and standards? And if there are standards, what's missing, what's wrong with them, or how we should expand them, or in general, what's the role of ontologies and standards for supporting product service systems? Anyone wants to get started on that?
I do a lot of standard stuff. I guess, okay, what else talking? So, yeah, I mean, we have a lot of gaps, all the way from our geometric models down, from design to engineering. If you look at like AP242, they're the BREFs with trim surfaces and just very hard to be able to address and reason over if you're looking at trying to understand design features versus let's say quality features versus manufacturing features and all these different terminology across the different aspects. We're missing the then connection from the engineering, the process engineering to the execution phase, because machines are dumb as bricks and the information that you get out of them is not relatable back to the actual process intent. So you can't have that back channel. You can try to go through geometry, but again, you're going through geometry to initial design geometry, which doesn't give you the stage model. So we don't have a stage model that really works. 238 does have it, but nobody uses it. So you're still dealing with like, G code and trying to back it in. So I guess in short, there are a ton of gaps in the current standards ecosystem that we have available to us through the step standards 10303s, all the way down to your quality and testing. CAE is, again, sort of in its own little space with tessellated models that you can't even, relate back without sort of humans in between. So we have all these fractious systems. We need to be able to bridge. There are some ways to be able to derive geometries that we can then use as comparators and hang data off of. We're working on some projects right around that right now, like the CCAM. That's where I see that, we can possibly try to draw some of this stuff together, but without ways of being able to connect up with what did I intend to do, what was the outcome, how did the data that I created relate to that? How did that fit to like my use phase, my sensors on my product, and how does that attach to the actual assemblies? And then feed back into the design for everything. That whole information flow right now is broken and fractious. So I can see a lot of places where we can patch the standards ecosystem that we have right now to start to bridge across some of these areas. I think there's some areas in like so for let's say ontologies, I see that they can start to bridge things like the different terminology we use in the different. Let's just take design process engineering, CAE. And execution. Bridge some of that terminology. What is the feature? What is a shape aspect? What is a, whatever, how do I talk about my services? I'll stop there.
Can I add something to that I think is missing?
Sure.
It's the time frame. Too often we're just looking at right here, right now. But with the service environment, we need to expand that, and we need to keep that consistent going forward, and potentially looking backwards as well. And I think that makes it really, really hard. So we continue to keep understanding what the current real state is, not the design state. And I think it's really challenging. I had a PhD student. He said it looks like a bunch of middleware trying to get different systems to talk to each other at the moment. Each one translating slightly differently.
Sebastian, you have
Yeah, I think I would add using ontologies might be, you said these gaps, bridge these gaps on top. I think we have in many factories like hidden relations. So you plant a factory, you have a production line, and then the reality is a little bit different because from the construction point of view, it's slightly different. So it's not according to the model what was planned. And in the production, these shift operators, they know this very well and how to operate their machines.
Yeah.
But we had this COVID. If the people are sick, who knows this then? The designer of the machine, obviously not. And I think this can be pretty nicely used with ontologies to
I think so.
Close this gap.
If I would add, then I would add something for academia, since we covered industry now. Well, my wish from ontology would be, for example, being an enabler for common understanding, increasing visibility of knowledge. But more important, I think it's an important building block for knowledge management, meaning sharing knowledge, developing knowledge, and adopting knowledge. I think this has to be emphasized a little bit more, because currently I'm at least in my research field of product service systems and servitization, I am observing that old concepts are just being renamed with new terminologies, making it really hard to build upon existing knowledge. And the one that grinds my gears the most would be, for example, circular economy. But nevertheless, I think your work is substantial, and I hope that we can bring that into academia as well a little bit more, and hopefully the reviewers then of journals and so on put a little bit more an eye on that. So that just my hopes and dreams for ontology, and I think it's applicable to industry as well, just different different mechanisms.
So any question from the audience? We have almost over time. Or I don't know how to check questions from online people. There is, well, I prefer not to mess with it. So is there any chat?
There is no questions.
Oh, okay. Yeah, luckily, yeah. Well,
Try that. There we go. I don't have a question. I'll just put one in.
all right. Great. Then, yeah, let's thank our panelists. Yep. So, and thanks a lot, Sean and Oliver. We are going for lunch. You have.
I'm disappointed about that. I would like to have a chat about the circular economy over lunch.
Yeah, let me. Okay.
Thank you.
Ciao, guys.
Last connection. But yeah, so we need. Oh, Arco is disconnected. Right? So I'll keep.